Okay, 5.3L, you're dividing whole numbers by fractions and you're dividing fractions by whole numbers. So we're gonna go over what's happening with this visually, and then we're gonna take a look at how to solve these problems using the keep, change, flip. When you see a problem like this, especially if you see a problem with a fraction, any fraction on both sides, or at least a fraction in one of the problems, and you see a division sign, then you think keep, change, flip all the time. That's the first thing that pops into your head. Keep, change, flip. And I'll write it right over here. Keep, change, flip. That's what pops into your head, period. And then you can go on from there. But before we solve this problem with the keep, change, flip, let me show you exactly what's going on with this problem. So we start off with 9. Those are 9 WHOLES's. So 9 holes. I don't care what it is. It's 9 holes of something. 9 kids, 9 cars, 9 houses, 9 pizzas. I don't care what it is. 9 things. And we're going to divide those 9 things by 2/4. So the first thing you can do, and once again, if you can draw a problem, you can solve a problem. If you can't draw a problem, chances are you can't solve the problem because you really don't know what's going on. So it's always good to be able to create a visual. Again, I promise you, you can create a visual, you can solve a math problem. So I've got 9 things. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hopefully everybody can understand that those are 9 things. I'm going to divide those 9 things into 2/4. Now this is my denominator says how many pieces I cut it into. 2 is how many pieces I have, or how many shaded pieces. So 1, 2, 2, 2, 2, 2, 2, 2, 2, 2. My 9 things have now been cut into fourths because my denominator says how many pieces to cut them into. Now I will shade each one of those things by the 2. So 1 representing 2/4 in all of the 9 holes. Hopefully everyone can see that. So I'm going to go right back again. I started with a 9. I drew 9 things, not too complicated. Whatever this number is, that's what you draw. We're going to divide that by 2/4. I therefore took each one of the WHOLES's, divided into 4 because that's what my denominator tells me to do. Did not divide it into 4. I shaded 2 because I have 2 of those 4. Now math comes down to one thing, and that's counting. If you can count, you can do math. If you can't count, you can't do math. You're either counting forward up the number line or back down the number line. On this one, we're counting forward, and we're counting by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I counted 18 shaded pieces of the 9 holes. So I'm going to put 18 right here because 18 is my answer to this problem. So let's come over here and take a look at the keep, change, flip method. When you see a problem like this, again, visualize it if you can. If you can't, see the division, think keep, change, flip. KCF. So I'm going to take this 9 and make it look like a fraction by turning it into an improper fraction. Any number can be placed over 1 to be turned into an improper fraction, because if I took this and divided it 9, 1, 9, 9, it turns back into 9. So you just put the whole number over 1, division 2, 4. So 9 ones, 9 over 1 divided by 2/4. I can't do this, so I have to keep that one the same, change the sign to multiplication, and flip the final fraction. And that's actually called taking the reciprocal of the last fraction. Now I can solve this. 9 times 4 is 36. 2 times 1 is 2. That's an improper fraction. We can take an improper fraction, turn it into a mixed number. And a mixed number does not always have to have a fraction with it, just like in this case it won't. 36 in the house, 2 on the outside. Little division action. 18. That's how you solve these problems. Draw a picture if you can. Keep, change, flip it as you can. And that's how you find the answer to whole number divided by fraction.